This video will be dedicated to the practice redemption task outcome 2 for the number patterns and sequences topic found in chapter 8. All up, there are two questions for this, or one question, sorry, split up into different parts. So let's have a look at this first part of the question here. PD wants to buy a second-hand jackhammer. He starts with $1,300 in an account and every month will add another $150. The amount of money in the account each month forms the following sequence. So it starts at $1,300 and it is going up by $150. Let J of N be the amount of money in the account after N months. We're going to write down a recurrence relation that models the amount of money in the account each month. Whenever we start a recurrence relation of some sort, we always start with J of N, J of 0, and whatever this initial amount is, 1,300. We then write what J of N plus 1 is equal to, and this is just J of N, so to get the next term, we have to get the previous term and add 150. We're just adding 150 in this case because he's putting $150 into the account, so it's accumulating money. So then once we've done this, we're going to use this recurrence relation to determine the amount of money in the account after 7 months. So right now, this is the initial amount. This is the first, second, third, and fourth month. So J of 5 is just going to be 1900 plus 150, and this is going to equal 2050. J of 6 is going to equal to 2050 plus 150, so this is 2200. And J of 7, which is the 7th month that we're looking for, is 2200 rather, plus 150. And this will give us $2,350. And that right there is our final solution. The second part, which I unfortunately written over the top of a little bit, that's okay. The number of months it takes for PD to save $2,800. Well, we're just going to keep going again. J of 8 is just going to be that amount plus 150, so that's 2,500. J of 9 is equal to 2,650, and all I'm doing is just adding 150 each time. J of 10 is equal to 2,800. So the number of months it takes for PD to save 2,800 will be 10 months. So therefore, 10 months. Ew, that seems like as though I have a virus and threat protection problem. I'm just going to ignore that for now. Alright, PD has found a jackhammer to buy but needs $3,000 to buy it. His friends will lend him the money but will charge him simple interest at the rate of $55 per month. Write down a recurrence relation to model this situation. So in this case here, we're just going to start with an initial amount. Now the recurrence relation, I'm going to be using the J letter again. And our initial amount that PD is going to borrow of his friends is 3,000. So if PD were to borrow $3,000 from his friends, and assuming that no months have gone by at simple interest, then what he owes back is $3,000. But then as 1 month goes by, what he owes back will be $3,000 plus one lot of $55, because as each month goes by, the amount of money that is owed back to his friends is going to go up at a rate of $55 per month. So the recurrence relation for this, to get J of N plus 1, this is going to be J of N, the previous term, and we're just going to add 55. But now we're going to write an nth rule, a rule to get the nth term for the above model. So to get j of n, so if we want to find how much is needed at any point, at any time, we're going to write the following term. So to get j of n, this is going to be equal to whatever the common difference is. So in this case, 55, and we're going to multiply this by n. So 55 n. So we're going to multiply this, and then whatever we find this out to be, we're just going to add the initial amount that it costs for that initial loan that was taken out from PD. Alternatively, you can write this as j of n is equal to the initial amount plus 55n. If this makes more sense in regards to the context, then you can write it in this way. All this is saying is give me an n amount, so whatever month it is that PD doesn't give money back to his friends. Say for instance it takes him 11 months. I'll substitute this into here, and then after 11 months I can tell you how much PD owes his friends, which is also including that $3,000. So we're going to use this rule to find how much PD pays his friends back if he fully repays the loan after 3 years. Now you've got to be careful, because a lot of students look at this and think, that's easy. If it's 3 years, let's just plug in 3 into this formula. But you've got to remember that this is $55 per month. It's per month. So 3 years, we got to figure out how many months there are in 3 years. So 12 times 3. This is 36 months. So be very careful with the context of the question. You've got to determine what the time frame is and convert accordingly to determine the number of iterations there are, or the n value. So for 36, j of n is just going to equal, I'm going to use this format here, I'm so used to this one, 3,000 plus 55 times 36. And when we plug this into our calculator, we'll move to the side here, all we need to do is 3,000 plus, now I always just put this in brackets just as a formality, it's $4,980. In other words, if PT does not touch this, does not pay back his friends for 3 years, and then he decides, okay, at the end of the 3rd year, I'll pay the amount, I'll make it a 3-year loan, this is how much he has to pay back. So there's an additional $1,980 worth of interest that goes back to his friends. Lucky friends. The next question looks at PD's jackhammer being depreciated. And this is using a reducing balance method. The value of the jackhammer after n amount of years, j of n, can be modeled by the recurrence relation here. If the initial amount is at $3,000, to get the next amount, we multiply the previous amount by 0.7. Now there's a key feature within this question. The fact that this 0.7 is lower than 1. If it's lower than 1, this means we're going to have geometric decay. Or in other words, the price of this jackhammer is going to go down by a certain percentage. And that's what we're going to look for now. So what is the annual interest rate? So the annual interest rate in this case is we're trying to figure out how much this is going down by. So there are different methods in obtaining this. What I usually do is I'll take that R value and I subtract that from 1. Then with this 0.3, I multiply it by 100. And this will give me the rate, the annual interest rate. Or in other words, this is decaying by 30%. So in other words, we find 30% of the initial amount and subtract it, and then the next amount we find 30% of it and subtract it, or we could just multiply it by 0.7. This will suffice, it's the same thing. So now we're going to write down the rule for the nth term in this scenario. To write down the rule for this one, all we have to do is we always start a rule with j of n. So recurrence relation, we always write j of 0 and then j of n plus 1. For a rule, it always starts with j of n, or whatever the letter of interest is of n. So j of n, take our r value, raise that to the power of n, and multiply this by the initial amount, 30,000. And then with this rule, we're going to see how many years it will take for the value of the jackhammer to first fall below $350. Now actually we're not using this rule, we're going to use a recurrence relation in conjunction with our calculator. So let's grab a calculator out again, let's go to menu, click on sequence. If there's something already there, let's just clear this, clear all, and we're just going to put in 0.7 multiplied by a of n, execute this, and set our initial value of 3,000. Now we want to see when it first goes below $350. So I'll set my starting value at 0 and my ending value, let's just go 25. Let's see how 25 goes for now. Press OK, get your table of values and resize this. So we're looking to see when it falls below 350. So it's going to keep going down by 30%. And when it hits 350, or when it goes past 350, at the end of the 6th year, it's at $352.95. Once that goes past the 350 value, as it keeps going down, it goes to 247. So on the 7th year, or within the 7th year, the jackhammer will first fall below $350. So within the 7th year. And just to give the teacher confirmation, I always like to write what j of 6 is equal to and j of 7 is equal to. J of 6 in this case was $352.95, so $352.95. So that is just shy of $350. But then J is 7, 247.06. 247.06. So how many years? Well, within the 7th year. That's how long it will take. That concludes this video. If you wanted to watch the videos for outcome 1 or outcome 3, there are separate videos to this. For now, have a go at these questions using this as a guide, and I will see you in the last video.